Where there is life, there is a human. Where there is life, there is a human. Where there is human, there is an idea. Where there is an idea, there is a try. Where there is a try, there is hard work. Where there is hard work, there is success. So, hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Yes, my dear students, today we are going to start with lecture number first based on the chapter D and F block elements under our batch Excellence Batch. So as you all know, our batch name itself says excellence. That means when we are going to do hard work as well as smart work, then we are going to excel in our field. So I guess students, all you have done is you have done the revision section that I have told you over in the previous chapter. You have revised that topics, and today we are going to initiate with the new chapter. So let us start this chapter with a wonderful, a beautiful smile. So yes, my dear students, as the chapter name itself says D and F block elements, so particularly we are going to focus first of all on the D block elements, then we shall proceed towards the F block elements. Is it clear? So the today's topic that we are going to cover in this particular session is going to be about the D block elements. That means first of all we are going to do the general introduction. We are going to do the general introduction to D and F block elements. We are going to study about what are transition elements. Students, we are going to see the physical properties of D block elements. Majorly, we are going to focus on the atomic radii of D block elements in this particular session. Yes, so let us start our today's segment, that is going to be the general introduction with respect to the D block and the F block elements. So if I talk about the general introduction, first of all, students, what are D block elements? My question is to you all. I guess you have revised the previous chapter, that was P block elements. So what was the definition of P block elements? We used to say that P block elements are those elements in which we say that the last electron enters into the p subshell. That were P block elements. Now over here, when I'm going to define D block elements, what will be my definition with respect to D block elements? These are those elements in which last electron enters into which subshell? D subshell. Quite simple? Yes. So what are D block elements? What are D block elements? So D block elements whose last electron enters into D subshell. Into which subshell? Into D subshell, are referred as D block elements. Now students, if I ask you how many orbitals are present in D subshell, my first question to you all is this. So you all are aware that D subshell contains how many orbitals over here? It contains 5 orbitals. Yes? Okay. So how many orbitals are present in the D subshell? It is 1, 2, 3, 4 and 5. So this is basically the D subshell. Now, if I ask you how many maximum electrons can be filled in the D subshell, so your answer shall be maximum electrons that we can fill over here is 10 electrons. Yes, how can I fill them? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That means maximum of 10 electrons can be filled over here. Is it clear to you? Now students, these were the basic things that you have studied in your class 11th standard. Now coming back to this particular chapter, if I revise, first of all let us give a quick revision to what we studied in 11th standard. If I ask you that what are the d orbitals present over here, can you name them? So you will say, ma'am, they are quite simple. They are very simple. They are basically dxy, dyz, dzx, dx square minus y square, and the last is dz square. Yes, you remember? These are the 5 orbitals that I'm talking about over here. Now, if I ask you, how do they look? So, you will make them, it is quite simple. Now, ma'am, they all are double dumbbell in shape. Yes? Okay. So, if I ask you, how does dxy is represented? So, if it is your x-axis and it is your y-axis, then do remember that dxy, dyz and dzx are the 3 major d orbitals in which we see that the lobes are present in between the axes. That means if it is my x-axis and it is my y-axis and I'm drawing dxy, that means the lobes of the particular orbit shall be present in between these axes. So this is the structure for dxy. For whom? For dxy. Now if I have to make the similar structure for whom? For dyz, let us say. If it is my y-axis, yes, and if it is my z-axis, again, dxy, dyz and dzx are the ones in which the lobes are present in between the axes. There is a very small difference between in between the axis and on the axis. This you shall see by looking at the particular structures over here. Now again, the lobes are present in between the axis. In between the axis. Now this is for dyz. Now if I have to draw for dzx, and if I'm considering this as my x-axis and this as my z-axis, then the lobes shall be present again in between these axes. In between these axes. This is xz. Is it clear to you? Or dzx you can say. Now students, these are the ones in which we say that they are present, the lobes are present in between the axes. In between the axes. Now let us draw the structure for both dx square y square and the dz square. Now if I talk about both of them students, then you should know that in both of these cases the lobes are present on the axis. Let us first of all draw the structure for dx square y square. Let us say that if it is x-axis and it is y-axis, then the lobes now will be present on the axis. How come? See, this is for, as you know, these are again double dumbbell in shape. So now this is the structure for dx square y square. Now if I have to draw the structure for dz square, over here, do remember this thing, that in the case of dz square, if it is your z-axis, the lobes shall be present like this. There is a ring-like structure over here. Basically, this is the structure for dz square. And this is the structure for dx square y square. Both of these structures, they are present on the axis. That's it. Its structure is quite different from all of these, but yes, it is again present on the axis. So over here we are talking about the lobes on the axis. And in these cases, we are talking in between the axes. So this was like the topic that we started in the class 11 standard, right? Now students, proceeding to what we have to study in this particular chapter are the D block elements. That what elements lie under the category of D block. We are going to focus on that particularly. Now if I talk about what other name I can give to D block elements are the transition elements. Yes, there is an exception. In D block elements also, there is one group that is referred to as pseudo transition elements. I shall be telling you what are they. But before that, let me tell you, if I talk about S block and the P block elements, they were referred to as representative elements or the main group elements. Okay. If I talk about the S block and the P block one, they were referred to as the representative or the main elements. But if I am considering the D block elements and the F block elements, D block elements are the transition elements, and in that case also I've told you there is an exception. I shall explain you in the upcoming segment. But if I talk about what are F block elements, they are referred to as inner transition elements. D block are transition elements, though there is an exception, but F block elements are inner transition elements. Now I will also tell you that why it is referred to as inner transition and why the D block are referred to as transition elements. So these are the basic things that you should know when you are going to start with the D block elements. I guess this is now clear to you. This particularly this very small information is quite, you require over here. So now let us proceed towards the next part. Yes. Okay. First of all, let us see over here. If I show you the periodic table, as you can see in this particular periodic table, let me tell you which are the D block elements. If you look up to the periodic table, these are your S block elements, group number 1 and group number 2. Okay, now from group number 13 to group number 18 that you have started in your previous chapter, they are P block elements. Yes, my dear students. Yes, ma'am. Okay. Now, from group number 3rd to group number 12, all the elements are referred to whom? They are referred to as D block elements. They are D block elements. And here that you can see, these are the lanthanoid series and the actinoid series. They come under the category of whom? The F block elements. So D block elements are basically starting from group number 3rd to group number 12, as you can particularly see over here. And the F block elements are given to you over here as lanthanoid series and as actinoid series. If I talk about lanthanoid series, in the case of lanthanoid series and actinoid series, why they are referred to as F block elements and why they come under these elements, come under the category of F block elements, again the definition will remain same, because over here in these particularly two series, we see that the electron either enters in the 4f and the 5f orbital respectively. Okay, so over here we can say that the last electron enters into the F subshell. That's why they are referred to as F block elements. Is it clear to you people? I guess it's clear to you. Now students, if I talk about these particular elements, the D block elements, as you can see, it is starting from scandium. Okay, whose atomic number is what? Okay, I'm really sorry. Whose atomic number is what? It's 21. And basically, it is starting from, the D block element starts from the 4th period. These are the very basic things that you observe from the periodic table directly. What I'm saying is, D block elements starts from the 4th period. You can even mention over here, they starts from the 4th period. Yes, students? Yes, I am using a red pen over here because I guess this is the white periodic table, white sheet of periodic table. Though I shall not use red pen over here, that I've seen in the comment sections. You all were facing problem in the red color, right? Okay, so I'll take pink color over here. So over here, as I've told you, basically, I'll mention over here. This is the 4th period, okay? So the D block element starts from the 4th period. You can observe 4th period, 5th period, 6th period and 7th period include the D block elements. Now, over here, this, as you can observe, just observe the periodic table. You can see there is lanthanum at, 57th atomic number. Okay. So you can see lanthanum over here and you can see 72 atomic number. You can see the difference from 57 to 72. Where are the other elements? The other elements are here. That means after lanthanum, the elements over here comes under the category of whom? The F block elements. Still 71 atomic number. Are you getting my point? From atomic number 58 to atomic number 71. That means if I talk from cerium, it is proceeding to lutetium. That is 71. They lie under the category of F block elements. Are you getting my point? Also, if you observe over here, if you observe under the next category, see, from again you can see from atomic number 89 to atomic number 104. Again there is a difference over here. Again there is a difference, though you can't see the difference anywhere else in this periodic table. That means again there is a series, that is actinoid series, that starts from thorium over here as you can see, and it is moving till 103 atomic number, lawrencium. Right? So they are also the F block elements. So basically, if I talk about these F block elements, they are a part of group number 3rd. They are a part of group number 3rd. They are a part of group number 3rd, but yet they come under the category of F block elements. So particularly in this particular session, we shall start with the D block elements. Though I wanted to give you a general introduction with regard to D block and the F block. Now you particularly know over here that when I'm talking about D block elements, they are starting from group number 3rd to 12, but in group number 3rd, we observe that from atomic number 58 to atomic number 71 and from atomic number 90 to atomic number 103, there are other elements that comes under the category of F block elements. Why they come under the category of F block elements? Because the last electron over them enters into the F subshell. F subshell. Now, the most important thing that you should know over here, the elements. The elements after 72, you can see these elements. or the elements after, I would say, 103. That means 104, 105, 106, 107, 108. They will have completely filled F orbitals now over here. Because over here you can see that there is a completion of F subshell, the presence of F subshell in these particular orbitals. After 72 or after 103, you shall be observing elements. They have the completely filled F orbital configuration. Now, when I'm going to tell you the electronic configuration, this thing that I'm telling you will automatically be clear to you. Great. Now, these are the very few things that you should remember over here, that they both basically, the lanthanoid and the actinoid series, come under the category of group number third. Again, they are basically, F block elements are basically referred to as what? They are referred to as inner transition elements, and they are former member of group number third. Group number third. Is it clear to you? Is it clear to you? And I hope so D block elements are also clear to you. I want you all to kindly mention all of these basic information in your periodic table as well. Right now, there are some of more information that you should know. Basically, now in organic chemistry, you observe that there is a reaction, that is hydrogenation reaction, and in that particular reaction, you use nickel, palladium and platinum as a catalyst. That means you are using group number 10 elements over here as a catalyst. So basically, these three elements are used for hydrogenation. Hydrogenation. So you should remember their group number. You should remember their group number. Next thing, if you look up to the group number 11 elements over here, group number 11th element that you can see over here, copper, you can see silver. Basically, what I want you all to understand over here, that these three elements, just I told you, for example, group number 10 are referred to as hydrogenation elements. That means they are used for the hydrogenation process. They use as a catalyst in that process. Similarly, if I talk about group number 11 elements, okay, and also you need to remember their atomic number, for whom I am telling you to remember. They are referred to as coinage metals. Okay, they are referred to as coinage metals. Is it clear to you? Now, the most important that you should know, and I was also saying you when I started this session, when I was defining you this particular definition, the elements of the group number 12, zinc, cadmium and mercury, they are pseudo transition elements. They are pseudo transition elements. I will tell you what are these, but first of all, I want you all to write these basic things in your periodic table. Either open up your NCERT or just mark over there. These three groups are really very important. Other than them, this thing is important, that from which particular period this shall start, and after that from which particular number the D block element starts, also from which particular number are the F block elements started, and till which number the F block elements are present. Also, one more question, how many F block elements are total present over here? If you see, in lanthanoid series there are 14 elements. Similarly, in actinoids also there are 14 elements. So total of 28 elements are observed in F block elements. Is that clear to you? Now students, moving on to the next thing, now we shall do the electronic configuration for all of them, right? Now students, okay, we shall write over here only. That would be the best way. Okay, if I talk about the elements of the 3D series, now see, as you all know, this is the fourth period. This one is the fifth period. Here 5 is written, see. This one is the 6th period. Similarly, this one is the 7th period. Yes, it is mentioned over here. This is the 4th period. This is the 5th period. This is 6th period. This is 7th period. It is mentioned over here. So, if I am saying over here, if it is 4th period, what shall be the value of n? N value will be 4. What shall be the value of n over here? It shall be 5. It shall be 6. It shall be 7 respectively. Right? Am I right over here? Now, when I am defining a general electronic configuration for D block elements, a general electronic configuration for D block elements, it is what? It is n minus 1 D 1 to 10, then again ns, it is 1 to 2. This is the general electronic configuration, though there are some exception in which you shall see that S subshell contains 0 electrons. But yes, this is the general electronic configuration, that is n minus 1 D 1 to 10 ns 1 to 2. Now if I talk about this fourth period, let me erase this first of all and let me write it over here so that you can mention it properly. Okay, I am just writing pseudo over here. Okay, pseudo transition elements. Okay, now see the general electronic configuration. What I'm writing over here is, if I want the general electronic configuration for the fourth period. Fourth period students are referred to as 3D series. Fourth period are referred to as 3D series. Why they are referred to as 3D series? Because fourth period, that means what is the value of n? N value is 4. If I put n value is 4 over here, what shall I get? I'll get 4 minus 1, that is 3. 4 minus 1, that is 3. See, fourth period refers to as n value is 4. That means I'll put 4 over here. 4 minus 1 is 3. That is 3D. Now it is 1 to 10. Now again, n value is again 4, no? So 4s1 to 2. So this is the general electronic configuration for which series? For fourth period. It is referred to as 3D series. Why? Because here 3D subshell is being observed. Is it clear to you? Is it clear to you? Again, I'm referring to you what? Here n value is 4th. That means shelf number is 4th. If I'm talking about fourth period, n value will be 4. I'll get this electronic configuration. So you can see the electronic configuration for the fourth period will shall lie between 3D 1 to 10, 4s 1 to 2. 3D 1 to 10, what do you refer to as 3D 1 to 10? Either the electron can be 1 in D subshell, it can be 2, 3, 4, 5, 6, 7, 8, 9 and 10, not more than 10. Why? Because we have just seen in the general introduction that D subshell will contain maximum of how many electrons? Of 10 electrons. That's why I have written from D1 to 10, that maximum of 10 electrons can come under this category. Now why I have written in S category only 2 electrons? Because S has only one orbital and one orbital contain maximum of 2 electrons. Similarly, if I talk about d orbital, it has 5, d subshell, it has 5 orbitals. So basically, if one orbital contains 2 electrons, 5 shall contain how many electrons? 10 electrons. It is quite easy. Yes, great. Now coming back over here, coming back to this category, when I talk about the fifth, let me take different colors. Okay, now when I talk about the fifth period, now there is an exception in fifth period. You can put a star mark over here. Again, if I talk about fifth period, again, if I talk about fifth period, that means n value is what? 5. Fifth period is referred to as 4D series. Why? Just see the electronic configuration. If I put n value as 5 over here, 5 minus 1 comes out to be 4D. Now 4D 1 to 10. Again, 5 you have to put in S, so it is 5s 1 to 2. But it is wrong. There is an exception over here that you shall be observing. The exception is that over here in 5s the electrons can lie from in this particular fifth period, in this particular fifth period, there will be one electronic configuration in which you shall observe that the 5 orbital contains the s orbital contains 0 electron. That means 5s 0 to 2. So this is an exception over here, but the general shall be ns 1 to 2. Okay, this is for the fifth period. This is for the fifth period, or you can refer to as 4D series. Which series? 4D series. Now moving on to the next one. Now moving on to the next part. Okay, now we have the next period, that is the sixth period. We have the next period, that is sixth period. Again, sixth period is referred to as what? It is referred to as 5D series. How come? Let us see. It is referred to as 5D series. How come? Let us see. See, sixth period, that means n value is what? It is 6, ma'am. If n value is 6, 6 minus 1 is 5. 5D 1 to 10. Again, n is 6, so 6s 1 to 2. So this is the general electronic configuration for which series? For 5D series. Is it clear to you? Now again, moving on to the last one, that is the seventh period. Moving on to the last one. Okay. Let us see the last one. That is, if I talk about the seventh period. Now, seventh period can also be referred to as what? It can refer to as 6D series. Here, what shall be the value of n? N value will be 7 because it is seventh period. So, if I put n value as 7, what I will get? I will get 6D 1 to 10, 7s 1 to 2. Is it clear to you? So, this shall be the general electronic configuration for this particular series. Yes, ma'am. Yes, ma'am. Is it clear? Is it clear? I guess this is visible to you. Okay. Now, students, one more thing that I want you all to understand over here, that you should know, just you should observe, that if I talk about 3D series starts from scandium, and it ends till zinc from 21 to 30. Okay, when I talk about the 4D series, it starts from yttrium to cadmium, right? Right. Similarly, if you see the 6th period, it lies from lanthanum to mercury. Yes, yes. Similarly, you can see the last period start from 89th element to 112th element. Is it clear? So I have written all the general electronic configuration over here. I want you all to write this or either take a screenshot of this particular page because it is quite really important page. Yes. So shall we start with how we have to learn these particular elements? General electronic configuration we have done. Okay, I'll tell you about transition elements, but first of all, let us do this thing. I will tell you what are transition elements, but first of all, I want you all to either write that. Is it clear to you? I guess all of you have written this thing. This, I guess everybody has written, right? Now moving on to the 3D series first of all. Moving on to the 3D series first of all. What are 3D series? Which period? It is 4th period. Now you know which period? It is 4th period. Yes, we have just seen right now it is 4th period. So it starts from which element? Scandium. Yes, scandium. Yes, ma'am, it starts from scandium. Atomic number 21. Okay. What is the trick to remember these elements? Ma'am, there are so many elements. Yes, there are so many elements. So how we will remember it? So I shall tell you a very simple trick. But before that, let us write first of all the elements. The very first element, the 21st element is scandium, which is represented by capital S, small c, scandium. After that comes titanium, capital T, small I. Okay, just give some gap in these elements so that you can write it further on. Now comes the vanadium, which starts from capital V. Then comes your chromium, that starts with capital C, small r. Don't just, get tensed. I will tell you how to remember them. First of all, just write it down. Then comes manganese, capital M, small n, manganese. Is it clear? Then comes your iron, represented by capital F, small e. Yes. Then comes cobalt, capital C, small o. Then comes nickel, capital N, small I. Then comes copper, capital C, small u. And then comes zinc, capital Z, small n. Right? Even if you want to write the name of the elements, you can particularly mention over here. It is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Is it clear to you? Right, now I shall tell you a very simple and a very cute trick that you will remember always. Now what is the trick? See, I am a science teacher. Yes. So science teacher, basically what it does, when you are studying organic chemistry, what do we do in organic chemistry? We explain you what is the reaction, what are reactants, what is substrate, what is product, what is intermediates. We explain you these basic things over there in organic chemistry. Yes, I guess you all are aware of these things. So basically we tell you the fundamentals of organic chemistry and then we proceed towards the reaction mechanism, explaining you what are the different kinds of mechanism that we study in organic chemistry. So basically a science teacher values chemistry mechanism, chemical reactions and the reaction mechanism. I meant to say that. So basically a chemistry teacher values them, right? So I have made a trick regarding that. If you have a quite easy trick to remember, then you can write in the comment section. That will help other students also, if the students find it easy in comparison to the trick which I am telling them, right? So you can do that with your name, mentioning that this trick you have made and you remember the elements in this form. So first of all, what I have made is science teacher. So from SC I have written science. It is basically science. Now from TI, I've written teacher, science teacher. Now, as I've said you, from V, I've written values because science teacher, values. Now from CR, I have written chemistry. From chromium, I have written chemistry. Okay. Now from MN, I have written mechanism. Now you can write in the bracket. I meant to say the chemistry mechanism, that is the reaction mechanism, or you can write the problems also here, all the problems with respect to the mechanism. So basically we value the chemistry mechanism. Now it is very simple. Okay, when a science teacher values the chemistry mechanism, or it basically explains you what is a reaction mechanism, how does a reaction takes place, or what are the fundamentals of organic chemistry, then you particularly get to know what is organic chemistry. So you build a faith in us. Yeah, yes, you basically have a huge faith on us that yes, we are going to explain you in a very simple manner and you are going to learn in a simple manner. So what happens when a teacher explains any subject, a student develops a faith in that teacher. So that what happens over here, a science teacher values chemistry mechanism, or I would say the problems that a student holds in organic chemistry or in reaction mechanism, or with respect to the fundamentals with respect to organic chemistry. Then what happened, it brings, now you can write brings is an extra word over here, so I'm writing it with white color. It brings, this is an extra word, it brings, I shall write it over here, it brings, what does it brings? It brings faith. It brings faith. From FE, it's faith. From CO, it's confidence. It brings faith, confidence. From NI, it's and. Basically, and is A and D, so I'm writing ND over here so that you can remember. It brings confidence, it brings faith, confidence, and. Now from CU and ZN, it brings confidence, faith, and. CU is comfort zone. From ZN, it's a zone. So this is basically the short trick for the 3D series. I shall read it for you guys. It is science teacher values chemistry mechanism of the problems, which brings faith, confidence, and comfort zone. Is it clear to you? Is it clear to you? When you get to learn something, when you understand something, you automatically automatically feel confident, and the pressure that you were having before understanding the topic and after understanding the topic, it all vanishes away. So that brings a comfort zone to you. So basically this is the short trick which I have made, and if you have anything else regarding this 3D series, you can write in the comment section. And the students who feel that this short trick is easy, or the trick which students are writing in the comment section, it is up to you which you want to remember. Basically you have to remember these elements for 3D series, for 4D series, right? So this is about 3D series. Now I shall be writing their atomic numbers. So as I've told you over here, that scandium starts from atomic number 21. Now titanium has atomic number 22, then is 23, then chromium 24, then manganese 25, then iron 26, then cobalt 27, then nickel 28, then copper 29, and then zinc 30. So I want you all to kindly write it down so that we can move on to our next, that is the 4D series. Kindly write it down, my dear students. Kindly write it down so that we can move on to the next series. I'm giving you a minute. Sorry. I guess you all have written. Shall we proceed to the next one? Okay. Before proceeding to the next one, let us do an electronic configuration of one of these elements over here, so that it will, we will be able to do them very, easily. Now over here in this particular series, which of the following can be used for hydrogenation process? That is nickel. I have already told you. In the periodic table we have marked over here. In the periodic table we have marked over there, right? So you should remember that 28th element is used for the hydrogenation process. Is it clear? Or we can say it is used as a catalyst in organic chemistry. Now if I want you all to write the electronic configuration for nickel, what is the atomic number for nickel? It is 28. So how shall you write electronic configuration? Now you know the general electronic configuration for this series we have just written right now. It is 3D 1 to 10 4s1 to 2. Why? Because over here, if it is fourth period, that means n value is 4. And what is the general electronic configuration that we particularly use? The general electronic configuration is n minus 1d 1 to 10 4s1 to 2. Yes, this is the general electronic configuration, and when we put n value as 4, we shall get this, right? So when I'm talking about, I'm really sorry for this. So when I'm talking about nickel, that means the atomic number is 28. 28. First of all, how many electrons are filled in argon? 18, right? So if 18 electrons are already filled in argon, then how we'll write electronic configuration? 18. After that, how many are left? 10 are left. So if you are going to write the electronic configuration, now you have to fill how many electrons? 10 electrons. So what shall be the electronic configuration? It is 3d8 4s2. It is 3d8 4s2. Okay, now one more thing. If I have to write how many electrons are present in 3D for all of these cases, how many electrons are present? Let us write that. See, if I talk about the very first one, the scandium, over here, how many electrons in 3D? 1. In titanium, how many electrons in 3D? 2. In vanadium, how many electrons are in 3D? 3. In chromium, how many electrons are in 3D? How many electrons are in 3D? Now you shall write 4, but it is an exception case. Here it shall come out to be 3D 5. In manganese, how many electrons in 3D? Again 5. In iron, how many electrons in 3D? It is 6. In cobalt, how many electrons in 3D? It is 7. In nickel, how many electrons are in 3D? 3D 8. Again, in copper over here, again there is an exception. Here it shall come out to be 3D 10. And how many in Zn? It is again 3D 10. Just write it down. Just write it down so that we can move on to our next part. Just write it down, students, so that we can move on to our next part. Yes? Okay. You'll say, ma'am, you have written for 3D. Why you have not written 4S? Yes, you can write it over here. It is 3D1 4S2. It is 3D2 4S2. It is 3D3 4S2. It is 3D5 4S1. In chromium, there is an exception. It is 3D5 4S2. It is 3D6 4S2. It is 3D7 4S2. It is 3D8 4S2. It is 3D10 4S1 in the case of copper. And in the case of zinc, it is 3D10 4S2. Okay? And in front of that argon is written, that means 18 electrons in that, and after that this is the electronic configuration. So see, nickel electronic configuration is 3D8 4S2. 3D8 4S2. Yes, I hope so. Now this is clear to you. I guess now this is clear to you. Now we shall proceed towards the next series, that is the 4D series. Let us see the 4D series. Now these are the elements that are present in which series? In 4D series. Yes. They starts from which atomic number? From atomic number 39th. If you see the periodic table over here, if you observe the periodic table, they starts from which element? From which atomic number? 39th. So let us write all of them. If it is 39, then atomic number for Zr is 40, 41, 42, 43, 44, 45, 46, 47 and 48. Yes, 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 students, kindly write them first of all. I'll let you know a short trick for this series also. Okay, let us start now. First of all, why they refer to as 4D series? Because here n value is 5. It is the fifth period. Yes, it is the fifth period. It is the fifth period. What is the general electronic configuration we wrote? We wrote 4D 1 to 10, 5S 0 to 2 for this particular series. Yes, yes, ma'am. Okay. Now, students, let us write their names first of all. From Y is yttrium. From Y, it's yttrium. From Zr is zirconium. From NB, it's niobium. Kindly check the spellings, okay? From MO, it's molybdenum. From TC, it's technetium. Yes. From RU, it's ruthenium. From RH, it's rhodium. From PD, it's palladium. From AG, it's silver. And from CD, it's cadmium. Yes. Kindly write out all of these. I'll see the spelling if there is any spelling mistake in any of these. Yttrium, zirconium, yes, niobium. Okay. Yes, in molybdenum, it's E will not come over here. It's directly BD. Okay. Okay. Yes. So, shall we proceed further? I guess all of you have written this. Shall we proceed now? Okay. Now I have written the atomic numbers. I have written their name. Let us write its trick also over here. So what will be the trick? Now this trick is basically based on the brands. Okay. I guess the one that loves brands. Okay. They will learn this trick very easily. Now Y stands for U over there. U. Okay. Now you will get, this is now whole comprised in Y. Okay. From Y, it comes out to be, you will get, let me do it a bit thick, okay? It is you will get. From Y, it is you will get. From ZN, from ZR, it is Zara. Now, Zara is a brand, right? I guess you all know Zara is a brand. Now, from NB, it is the trick which I have made. You can make on your own also, and if it is easy, you can learn that also. You can write in the comment section. Students, if you find this trick to be easy to learn, you can do that. If you find another trick to be easy, you can learn that. Okay, it is up to you. From NB, I have written Nike. Yes, Zara, Nike. From MO, now MO stands for Monte Carlo, right? It is also a brand, right? Now from TC, now basically this, see, in this Monte Carlo, this basically is for Monte Carlo and technetium both. How come? See, I'll let you know. From MO, it's molybdenum. From TC, that is T Carlo. From TC, it's Monte Carlo. Now from MO, it's molybdenum. From technetium, it is T Carlo. Or TC is also a brand, clothing brand name. You can learn directly that also if you don't want it to be combined together. So you can say TC directly also. Okay. So Monte Carlo. After that, now I have two brands. You can, put anywhere if you want. One is Ray-Ban, another one is Reebok. So from from RU, I have taken Ray-Ban, and from RH, I have taken Reebok. Yes. Now from then you have PD, AG, and CD at last. Now see basically what happens. From PD, we have Pepe Jeans, right? Now this is also a brand name. Now you have AGCD. Now see what is my trick over here. You will get Zara, Nike, Monte Carlo, Ray-Ban, Reebok, Pepe Jeans. Okay, agencies. Now see everyone, it's a wish for everyone to get these brands, right? So some of the students, some of you may like or some of may not like. It is up to you. I am just making a trick so that you can remember. Now from AG stands from agencies. AG stands for agency. Okay. Now how you will get these? With cash? No, you will get their agencies with cash. Now there is an extra word over here. There is an extra word with over here, and then comes cash. So if you want all of them, you need cash. Yes. So this is the short trick. This is the short trick. You will get Zara, Nike, Monte Carlo, Ray-Ban, Reebok, Pepe Jeans agencies with cash. Kindly write it down so that we can move on to the next series. Kindly write it down so that we can move on to the next series. Yes. Can we move on to the next series? Okay, let us start. Now comes 5D series and the 6D series. 5D series and the 6D series. Now we have already done the general electronic configuration. This is the 6th period one. And the 6D series lies for the 7th period. Am I right? Yes, ma'am. Now, if it is for the 6th period, what is the general configuration? It is 5D 1 to 10, 6S 1 to 2. What is the general configuration for 6D series? It is 6D 1 to 10, 7S 1 to 2. Because here n value for 7th period is 7. Here n value for 6th period is 6. And what was the general electronic configuration that we used to say? N minus 1D 1 to 10. NS122. Yes, yes, ma'am. Yes, ma'am. Okay, now one thing from over here, if I start from the very first element, it starts from the 57th atomic number, and I've already told you over here, hafnium, if I'm talking about, it has an atomic number of 72. That means it is 73, this is 74, this is 75, this is 76, this is 77, 78, 79, and 79 and 80. Yes. So over here, the elements that lie between 58 to 71 comes under the category of F block elements, that are the lanthanoid series. Yes. Okay. Now you can also mention it over here. 58 to 71 are the F block elements. Yes. Similarly over here, if I talk about these elements, it starts from 89. Actinium is 89. Are you getting my point? Now over here, if you talk about rutherfordium, it is 104. It is 104. That means elements from 90 to 103 again are the F block elements, and they are the actinoid series. Yes, my shimmering stars, this is clear to you. This was a general thing that you should remember in 5D and 6D, nothing else. Nothing else in these series. Right? Right. Okay. Let us proceed further. Let us move on to the next part. Let us move on to the next part. Now, students, when I talk about the electronic configuration, now there is a homework for you people. I will be giving its answers in the next lecture. Really sorry. I shall be giving the answers in the next lecture, but I want just try it once by yourself. Okay, so you have to write. Now, this is your homework question. We shall write in the homework segment only. So, there is a homework question for you all. Write electronic configuration. Okay, for them. Okay, now I'm giving you first question over. See, basically what happens when I'm giving some questions to you people, I want your answers to come back. Now, when you are answering me in the comment section, that makes me able to understand that yes, you people are learning something out. See, many of the students don't write in the comment section. Why? Because they feel shy. They feel that if the answer comes out to be wrong, then what ma'am will think about me. Ma'am will think nothing about you. Ma'am will think so positive about you that yes, you are participating in what I want from you all. The participation is really very essential. Either just feel shy and sit at your place and just you will not able to learn your mistakes, learn from your mistakes. In order to learn from your mistakes, you have to participate. So if I'm saying, you just write in the comment section whether it is right or wrong, write it over there. I always say this to my students, whether your answer is right, no, it will be a plus point for you. You can give yourself a treat, like of a chocolate, of a of a good sweet that you like the most, or of a good food that you love the most. Just tell to your mother that today I have done all the questions correct, kindly make this particular food for myself. And if your question is wrong, my dear students, and you have written in the comment section, then that is a promise to you and to myself. You have to do that promise to yourself, also to ma'am also, that ma'am, today if I'm writing the wrong answer in the comment section because I thought it was this answer, but it is not this answer, but yes, I'm still writing in the comment section, that means I'm promising you in the next time that when you will give me any homework question or any question, then I will be the one who shall be writing the correct answer. So basically this is a policy that you are promising me out, that yes, if today answer comes out to be right, it is a good thing for me. But if it is wrong, then also it is a good thing for me, because it motivates me that next time I have to do correct. So that way, when you are writing in the comment section and your answer comes out to be the wrong, when you are looking up to the answer in the next lecture, it will be a lesson for you that, oh my god, I've done this question wrong. That means next time I will remember that question. Automatically you will remember. But if you're not writing it, you will forget it. So do this. It will help you out. Trust me. Trust the process. Now I'm giving you some of the questions. I want you all to write it down. See, you have to write the electronic configuration for Cu, for Cr, okay, for copper, for chromium, for Ag. I want you have to write it. I will tell you how to do it. If you feel it's tough, no problem, my dear students. I will let you know. For palladium, Pd. Okay, let us write for cadmium also, for Cd. Okay, let me give you one. Okay, for lanthanum, La. 6 homework questions for you people. I just want you all to write the electronic configuration in the comment section with your name. Very simple thing I have given you as a homework. It is not that tough. It is not at all that tough, right? Now coming to the topic which I've already told you that I shall tell you, I shall explain you, that is transition elements. What are transition elements and what are pseudo transition elements? My question is to you all people. See, if I talk about transition elements basically are the ones in which we can see there is an incompletely filled d orbital. When there is a incompletely filled d orbital configuration either in the ground state or in its excited state. Understand the two major words, ground state and the excited state. What I am saying, when there is incomplete d orbital configuration, they are referred to as in ground state, in ground state or excited state, they are transition elements. Example, let us talk about chromium. Atomic number 24. What was the general electronic configuration? Argon 18, and after that I told you there is an exception over here. What it was? 3d5 4s1. This was the exception over here, right? Now if I have to write if I fill these electrons in the d subshell, basically it is 1 2 3 4 and 5, 3d5, and in 4s it is 1. So basically this is 3d5 4s1. So are they completely filled? No ma'am, they are not completely filled. Is it 3d10? No ma'am. That means it comes under the category of whom? Transition elements. When there is incomplete d orbital, d subshell, okay, incompletely filled, that means it is what? It is your transition elements. Is it clear to you? Now there is an exception. What is an exception? All the d block elements are not transition elements. Exception is there. Exception is your group number 12. Exception is your group number 12. Group number 12 are pseudo transition elements. Group number 12 are pseudo transition elements. Why they are referred to as pseudo transition elements? Because they have completely filled, because they have completely filled d subshell. What are the examples over here? They have completely filled. For example, zinc, cadmium, mercury, they have completely filled d. Okay, if I talk about zinc, it is 3d10 4s2. It is 3d10 4s2. It is 3d10 4s2. Now, in which state? It is in ground state. What is its excited state? Basically, zinc has an oxidation state of +2. That means if you remove these electrons, now if 2 electrons are removed, what shall be the Zn +2 configuration? 3d10 4s0. Still the d orbital has fully filled electronic configuration. Even in ground state, in excited state, both I am talking about. In ground state, excited state, both state. It has 3d10 completely filled d orbital configuration in both the states. That means here still if the configuration is full, then it means it is not a transition element. It won't do any transition. Hence they are also referred to as colorless. They are also colorless. They are also colorless. Also they refer to as pseudo transition elements. Kindly write it down, students. Kindly write it down so that we can move on to the next part. Yes, okay. Now let us move on to the physical properties. We shall start with the physical properties. Okay. Okay, we shall start with the physical properties with regard to the chapter, that is d block elements. First of all, we shall talk about the d block elements. Now all the d block elements are metals. All are metals. Now they are malleable also, they are ductile also. They are malleable and ductile. Okay, now what is malleable and ductile? You all are aware with these things, that can be beaten into thin sheets and the thin wires, right? They have high thermal and electrical conductivity as well. They have high thermal and electrical conductivity. Now, if it is metal, then it has luster also, okay? And they have high tensile strength. They are lustrous. Okay, so these are the physical properties that we talk about. Now comes the next property, that is atomic radii. But before moving on to the atomic radii, we shall complete this particular session over here only. I want you all to write the electronic configurations, hold a command on electronic configuration, so that we can move on to the next physical properties and the next topic. So yes, my dear students, today we shall end our segment over here only. But before ending this particular session, I would tell you a very simple thing, a very basic thing that you should keep in your minds. Success is speaking words of praise. Success is speaking words of praise in cheering other people ways, in doing just the best you can, in doing just the best you can with every task and every plan. So just prepare a timetable of your daily. Keep a timetable for yourself. Just moving on to the next day, yesterday's night, prepare the schedule that you have to do on the next day. Follow that. Also, one more thing I always say to my students, inorganic chemistry is basically a subject in which revision is required the most. If we have completed the P block elements, you have to revise it also. Also, you have to practice as many as question as you can. So basically, when I've given you some of the questions over here as a homework, your responsibility is to read the particular topics that we have studied in this particular session from the NCERT, and then your basically focus is to solve the questions also that I've given you over here. So that when you have a command in electronic configuration, then you can directly write the electronic configuration and you'll get to know the properties itself. Now, in the next coming segment, when I'm going to write the 3D series, the 4D series, I want you all to write before I write over here, right? So how will that come? When you'll practice more and more. So we shall meet in the next lecture. I want you all to revise what we have done in this particular session, and we shall meet in the next lecture covering the next topics. So till then, keep smiling, keep learning. Thank you so much and have a good day.